When used correctly, the loop over items node will save you from a very long list of n8n headaches. Unfortunately, it isn't very intuitive. The way it connects back to itself, the done and loop outputs, it can feel like one of the most confusing parts of n8n, especially if you're coming from other platforms like Make. The good news is that there are really only three scenarios where you'll use the loop over items node, and by the end of this video, you'll be an expert at all three. Let's go. Okay, here are the three different scenarios, one in green, one in blue, and one in purple. The first one is rate limiting, and we'll go into a lot of detail, so I'm just going to introduce these first. The first one's rate limiting. The next one is node exceptions, which are just certain nodes in n8n are going to require you to use the loop over items node in order to perform these successfully or as expected. And the last one is pagination. And the first one, rate limiting and pagination, are going to be your most common occurrences, or the most common times that you're going to use the loop over items node. We're going to go over rate limiting first, then we'll go over the exceptions, and then we're going to go over pagination last. So make sure you stick around to the end to see this other very, very common use of, of the loop over items node, or the loop over items at least concept. So we're going to start here first, and we're going to go through a number of examples so that we can cement this idea in our minds with concrete examples. So the first one here is going to be by using an API that's called Massive, and Massive is it's an API that returns stock market data. So what we're going to do is we're going to feed in tickers, or the ticker symbols, into this workflow, and the Massive API is going to return the data back for those tickers on that API, or on that stock. So we're going to input a trigger manually, and then we're going to run this. And we're going to notice over here there's some details. The first is that we're going to get 5 tickers, which is shown right here. 1, 2, 3, 4, 5. Apple, Microsoft, Google, Amazon, and I think NVIDIA. I'm not totally sure. But 5 of some of the most popular tickers. And then we have our Massive API request right here. And we have a few settings. The notable settings are that on error, it is going to stop workflow. So that's right here in settings. On error, stop workflow. And we're not going to run into an error in this case because our rate limit for the Massive API is 5 requests per minute. So if we execute this, we're not going to get an error. And it's going to return back the data for those 5 tickers. So you can see Apple, then you can see Microsoft, and primary exchange, the currency name, all the data that's associated with these tickers, 1 through 5, NVIDIA. Um, so yeah, no errors occurred. But now that we've run that, we're going to show what it's like to run into a rate limiting error. So on this next one, this is going to be almost identical, almost the same thing, except for the fact that we are now going to be running or requesting for 6 tickers. So you'll see that we now added meta on the end. So because our rate limit is 5 per minute, and we're going to run 6 successively, it's going to hit our limit, and we're going to get an error right here. So we'll execute this workflow, and you'll see that we got this error problem in Node. You may not be able to see it behind the little camera, but problem in Node, massive example 1, the service is receiving too many requests from you. And this is a very common thing to have happen in API requests. And you'll have to look through the documentation for the particular API that you are making a request to, because each of them are different. But we clearly have reached our limit here. We made more than 5 requests in a minute, and so it threw this error. And the purpose of the loop over items node is to avoid these errors, because what happens natively in this node is that you feed it 6 items, and you can see that here. I'll move my mouse so you can see it. Look right here when I move my mouse. You can see that 6 items were fed in. And the way that n8n handles this, especially with the HTTP request node, is that it will automatically loop over each of those items and make a unique request for each one of those individual items. And it does it very fast, faster than your eye can see. But it actually hit the API 6 times because it fed it 6 items. And this does this out of the box. And so if you're having problems with rate limiting, if you run your code straight into an HTTP request when you pass it multiple items, that's why. It's because it makes a bunch of requests in succession, 6 in this case. So now we're going to show what it would be like to introduce a loop over items node in this. Now, this particular example right here is still going to cause a failure because we don't have any weight nodes in here, and we'll show that in just a minute. But I just want you to see how this is similar in terms of how it is executed. So in this example, just like the last one, we are going to request the information for 6 tickers. So if we open this, we'll see that we have 6 tickers right here. So without a pause or without a wait, it is still going to cause us to hit an error. So we'll just show that, we'll just demonstrate that. So you'll see, again, we got the same error with down here in the corner. Again, you probably can't see it because of the camera in front of it, but problem in node, massive example 2, the service is receiving too many requests from you. You can see that it happened again. We have these 6 check marks. It happened on the 6th request. So we're going to open this and see the service is receiving too many requests from you. We exceeded our maximum request limit, which is again 5 per minute. So this worked very similarly as the last one, except now we're breaking it out and we're doing one at a time, and we have access to the functions in between those iterations. And we'll show that right here. So on this one, now we're changing, we're going to up it to 10 tickers, and we're going to wait now 5 seconds. We are still going to get an error because we are accessing now 10 tickers and only waiting for 5 seconds. So that will happen we will hit our limit in 25 seconds. Before, it was happening almost immediately because those requests happened so fast. But now it's going to be 25 seconds until we hit that limit. So we'll bring down the trigger and hook it up. And then we'll run this and we'll see that we're going to get an error again. So here it's waiting for 5 seconds, waiting for 5 seconds again. It's on round 2. And sometimes we might have rollover on the minutes, but we will see now that we did hit our error. And if we open it, it's the same error. The service is receiving too many requests from you. We've exceeded our limit. So even though we waited 5 seconds, we still hit our rate limit because we made more than 5 requests in a minute. But we can see that we're getting a little bit better because we can add this wait node in here. So instead of all these requests happening one right after another, we've introduced a pause here for 5 seconds, which is getting us closer to solving that rate limiting error. So now we're going to go on to this next one, and instead of waiting for 5 seconds on this one, we're going to wait for 12 seconds, which 5 times 12 is 60. So this puts us right at our limit. That will make 5 requests per minute, and we could keep doing this forever because our limit is only 5 per minute. And so we can make the 10 requests, or we can get the information for the 10 tickers. It's going to take us 2 minutes to do so, but we won't hit our rate limit by using this. And this is really where the power of the loop over items node is demonstrated. And so we'll start that, we'll take our trigger, we'll move our trigger down here, and we'll press execute workflow. Okay, so now we can see that the workflow was executed successfully. So we got all 10 of our ticker data. So we got all 10 responses back. If we open this, we can see we got all 10 of the results because we put this pause in here for 12 seconds. So we never exceeded our rate limit of 5 requests per minute. Now this is a great place, since we did get a successful execution all the way through the loop, to talk about these 2 outputs right here. So you'll see right here we have 10 items again that came out of this code node. So we can see those 10 items are these tickers. And we have 10 items that exited through this done branch, or this done output. So what happens is that this loop over items node right here is going to read how many items are being fed into it at the very beginning, and it's just going to keep track then. So it sees 10 items and it just knows we need to make 10 trips over this loop, and as soon as we make 10 trips, we're going to exit out this side on the done side. So until we've made 10 trips around the loop, it's going to go through, make the request, wait for 12 seconds, come back, enter again, and see if it is on the 10th loop or if it is less than the 10th loop. And if it's on the 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, or 9th, it's going to then say, okay, well then we go out this way and we make another request until it does 10 total items, and then it says, okay, we can exit and go out this done route. And the cool thing is that it passes all of the items from each one of the loops out to us in one place, so that we can see them all right here, which is great. So this is a way that we can get past rate limits automatically. We don't even have to, we just set it up and then it works. Now, we could stop here, but we're going to show a couple more examples that make it even more robust and make us even less error prone. So we're going to go on to this next one right here, and it looks similar, except we put a condition in this request right here. So here in bold are the things that we've changed. So here on this first request, instead of having a stop workflow, we did on error continue using error output. And so we can show that. You'll remember on the first example that this was stop workflow, but here it's continue using error output. So what that does is it opens up another branch. If we look up here on this one only had one branch. Down here, this one has two branches. So when we get an error from the API, or we get an error in the response, it's going to exit out of this branch and go do whatever logic we have set up on this route right here. So in this case, when it errors, it's going to go and it's going to wait 5 seconds. And then it's going to try making the request again to the API. And once it does that, in this case, because this one's settings are at stop workflow, it's going to just error right here and stop everything if indeed it does error. Now let's go back again and we'll talk about the success branch. If the API request is successful, it is going to come outside, it's going to come out this success branch. It's going to wait 5 seconds, and then it's going to loop back and go on to the next iteration in the loop. Now, we have designed this so that it's going to error, as you may have guessed, because both of these only wait for 5 seconds. And so we're going to get here, and it's going to it's going to stop the workflow. So let's get our trigger. We'll execute the workflow. So you can see for the first view, it's going to be successful, but then it's going to have an error and it's going to go out this branch, and this wait node is going to be activated. And then it will reattempt and it's going to hard fail here. It's going to stop the workflow. So there we see that it has started into this branch at a failure, and now we have a hard failure. Again, because we didn't have a continue, it says the service is receiving too many requests from you, and it failed because we went over our rate limit of 5 requests per minute. Now, I just want to add in here that you can download this workflow and use it as a reference, so that when you're trying to get used to the loop over items node, you can just look back to this and see a bunch of different examples that will help you reorient yourself to the loop over items node. So now we're going to go on and we're going to add in a more secure way of doing this, a more robust way of doing this on the next example. And in this example, what we're going to do is when it fails here, and when there's an error from the API because we get a rate limit error, it's going to come to this node, this wait node, and it's going to wait for 60 seconds, which will totally refresh our rate limit and give us kind of a new slate, a clean slate. And then after that, it's going to re-request the same exact ticker that was in this one. So the ticker stays the same in this case. Let's take Apple, for example. When it enters here, Apple is the ticker that these nodes are reading. So it'll come here, it'll request for Apple. If it's successful, it'll move on, it'll wait for 5 seconds, and then go on to the next one, which would be Microsoft. But let's say that for whatever reason, and it won't happen in this case, but let's say that on Apple, it were to error, it got a rate limit error. It would go here, it would wait for 60 seconds, and since we're still in the same loop, the value of the ticker is still Apple. So that means that when we request it here, the ticker is still going to be Apple. So basically what we're doing is we're waiting 60 seconds. We're going to let our rate limit refresh. and then it's going to re-request the same ticker as we did in this one, so we make sure that we don't miss any of the tickers that we wanted to get back. So let's show this working. Let's get the trigger and we'll execute the workflow. So there we have it. It got to 6, and now it's going to go and it's going to wait for 60 seconds because it errored. We hit our rate limit. Now once it's done waiting, it's going to take the same ticker. We can look at this. It's going to take the same ticker and it's going to go and re-request it and then move on to the next iteration in the loop. So now we finished the whole loop and we're going to see that we got all 10 items out. And this is a huge win for us because we know that this part of the loop experienced one visit. So it errored here, and the nice thing is that we didn't lose that information because we waited and we re-requested for that same ticker. So we were still able to add it to our output. So this makes it so that we don't have holes in the data that we receive back just because we have an error. So this makes this workflow a lot more robust and guarantees there's a much higher guarantee that we're going to get the results that we want out of this. So you can see really you start to see the power of this loop over items node because it gives us ultimate control over error handling and over rate limits so that we can have a higher likelihood that we get the information back that we want from the APIs that we request. So it's really, really powerful. And these can get more complicated than this, of course. But this is a lot of times probably to the extent that you'll go with rate limiting in terms of complexity for these workflows. But it's only a few nodes, and it just makes the reliability of our workflow much, much greater. So we could in there, but we're going to go on to another one and just show you one more example. It shows you what happens if we do a continue using error output. In this case, you'll see that we're going to actually lose some of the data. Just to give you another example, to contrast this last example. So we'll bring the trigger down here. And the difference is that we're going to wait for 5 seconds, not 60. So we're still going to trigger an error. But now instead we've put a success in an error loop here. And the way that this loop over items handles errors in this configuration that we have it is it's going to add that error to our output, not the ticker information that we want. So we'll see that in just a second when we run this. So we're going to execute this. Okay, so now this has completed. We're going to go in here and we're going to see that we got an error. So this shows you, just in contrast to this one, how the error coming out of this HTTP request affects the output. Now, we're going to look at this example. We're not going to run it because it waits for 60 seconds here. And you would think now that there wasn't any reason to put an error output here because this looks just like the one that we did right here, which was wait for 60 seconds. The only difference now is that we have an error and a success branch that we've created here. Now, the reason that we would do that is because sometimes in our API requests, we get errors other than rate limit errors. And if those happen, we want to see what those errors are so that we can come back in our workflow and we can correct the workflow such that it will handle that error or avoid that error. So in this case, it would, if there was something, because it will not hit a rate limit error, and we know that because we wait for 60 seconds whenever the first request happens and we get that rate error, it waits for 60 seconds, re-requests. So we're never going to run into a rate limit error in this workflow with this particular API, but we may encounter other errors. And we want to make sure that if those errors are thrown, that we receive them in the output so that we can learn how to make our workflow more robust and ready for all types of errors, not just rate limit errors. So there are a lot of different options you can do here, but this just gives you tons and tons of control that will make it so that your workflows are less likely to have errors. So as you can see, uh, the loop over items node can be very, very powerful in the right scenario, and rate limiting is certainly one of the forerunners in terms of opportunities to run the loop over items node. So that pretty much covers, now there are an infinite number of ways that you can configure these workflows using the loop over items. But we went over a lot of the use cases, and certainly the majority of use cases, uh, at least some example of them here. So again, you can download this workflow. There's a link in the description that will take you to automationhackers.net, and you can create a free account, and then you'll have access to not only this workflow, but all the workflows in every video on the channel that you can download for free. So now we're going to move on. Again, we're going to go over to pagination at the end. This is another one that's very, very common. So we'll end with that. But we're going to go through this. We're going to go through node exceptions first. Now, these node exceptions are basically just outliers in terms of how most nodes function inside of n8n. So if we go back here, you'll remember that we passed 5 items or 5 tickers into this HTTP request. So this HTTP request node automatically knew to make 5 different requests. So it automatically loops. Again, we get more control with the loop over items, but this node right here is built to automatically loop when it receives multiple items. But some nodes in n8n, well, I'll say most nodes are built to loop in some form, but these are exceptions to that. So you have your CrateDB nodes. So if you ever find yourself using a CrateDB node for an insert or an update, then you're going to have to use a loop over items node in order to go through if you pass it multiple items, uh, because it won't do it automatically out of the box on its own. It will only do one per uh, per per node. The other one is your code node, and this is particularly so if it's in run once for all items mode. You can change the modes, but it defaults to run once for all items mode. So you would want to use a loop over items node in that case if you're in that mode. Then the other one is execute workflow, which executes a sub workflow or a different workflow within your n8n instance. It will run in run once for all items mode. You can, you can modify that, but just so that you're aware, that happens. Then the HTTP request, in terms of pagination, we'll get to that and then over here in the next one. But you'll have to configure it for pagination, or if you're hitting the rate limits, you have to use the loop over items node. And then your Microsoft SQL nodes for insert, update, and delete. Now this is coming straight from the documentation of n8n, so these are, this is an exhaustive list of the ones at least at the time of this recording. MongoDB is also for the insert and update nodes. It only by default manages one at a time, so you have to use loop over items. QuestDB for insert, Redis for get, RSS feed, it executes once per requested URL, and then timescale DB for insert and update. If you're using these, you have to use loop over items node. So now let's go on to pagination, which again is a very, very common use case for looping in n8n. Because many APIs they have limits on the number of items that they'll return in one given request. For example, maybe they have a limit of 100. And in this case, Airtable has that limit. So if you're requesting data from an Airtable table, it will only return 100 items at a time. So if you have more than that, say you have 200, 300, 400 or more, then you're going to have to make multiple requests in order to get the rest of the data. Now, the nice thing, if we open this and look through this, in the HTTP request node, there's an option for pagination. So you can configure it to handle pagination. And then there are a couple different modes. You can turn this off, or you can response contains next URL. In our case, for Airtable, we need to change a query parameter. And the query parameters are just when you see a URL and it has a question mark and then a bunch of other stuff, those are query parameters, which tells the API what, it's almost like a filter. It will get a little bit more specific in what you're searching for. So that particular query parameter is offset. So you would see in a full URL you would have a question mark offset equals and then something. And every time we loop through a request here, an HTTP request, the Airtable is going to send back the data that we requested, and then it's going to send back an offset item or an offset key value pair that essentially tells us the next place that we need to go, or the next URL that we need to request to get the next 100 items. So we have set up here our complete expression, which basically tells the HTTP request when to finish or when to end. And just basically, we don't know. In many cases, we don't know how many times it's going to need to make a request, because it might be an indefinite number of things that we are trying to request. In this case, it's a table that we built, so we know how many items there are, but when we're requesting from other APIs, we may not know how many items it's going to return. So we need to put a complete expression that in this case, when offset is no longer included in the response that we get from the API, then we stop, because it means that there are no more pages to loop over. So that is our condition. Once offset is no longer included in the response that we get from the API, this complete expression will evaluate as true. We're nodding it. We're putting this little exclamation point at the end. So so when it evaluates to true, or really when offset's not there, it'll evaluate to true. We're taking the opposite, and then this will end. And one cool thing is that we can add an interval between requests, so we can kind of simulate what we did with loop over items. When we did a wait, we can say we want it to wait for 1,000 milliseconds, or which would be 1 second. We can put a pause node in here. It's not quite as robust, so you still will probably want to use loop over node, but we're just showing that this is possible natively in the HTTP request node. So now we're going to execute this step, and we're going to see over here in the output that we got 9 items. So there are 9 separate items here of 100 different results. So here's another one. This is another item with its own set of records, and there will be 100 of these little objects inside of this records array, and there are 9 of them. And indeed, there are 900 entries in the table. And if we were to take, let's just do an example without the pagination. If we were to delete this and we execute this step, what's going to happen is that we're only going to get 1 result. So we'll only get 100 records. So this shows the difference. In this case, we got 900 because we enabled pagination, and in this one we did not, and the limit is 100, so we only got 100 items back. So this kind of shows you how to do pagination within the HTTP request. If you're going to have a more robust way of handling pagination, then this would be a good example of how to set that up. And I know that we don't use the loop over node, we could, but this simulates the loop over node with pagination. And this allows you now, it looks a lot like what we did with loop over node, this allows you to then submit or put logic in between these requests that gives us more control, just like in the loop over items node. So if we wanted to put a wait here, if we needed to put a wait, in the case of the Airtable request, we don't need to put a wait because our limits are just so high that we're not concerned about it with requesting just 900 items. But if we needed to put a wait in this loop, we could, and we would be able to have that control to help it avoid any rate limit errors or any other errors for that matter. So if we take we got to get the trigger node from down here. So we'll delete that link. We'll bring it up here, and we'll see a very, very similar result when we run this. So we're going to hit execute workflow. You're going to see it go, and it'll show you 2, 3, 4, 5, 9. So we got 900 items out. Very similar to what happened up here, but instead we didn't have pagination here. We just kept it. Without pagination, and we did it ourselves to give ourselves more control. So you are going to see pagination very, very often in your API requests that you make, and you're going to see rate limiting errors very often. So this concept of looping over items is very, very powerful and will save you an enormous amount of headache when you're running into errors that are driving you nuts because these nodes are just kind of built how they're built. And if you don't go in and give yourself more control, then you're just going to kind of be up a creek because those errors are just going to happen. So very, very powerful node in these use cases. This is pretty much an exhaustive list of use cases. There are only 3. And if you get these down really well, then you're going to be very, very comfortable with a loop over item in this node, and you're going to avoid some real headache that a lot of people run into when having lower rate limits or pagination issues. So that's everything for today. If again, you can download this workflow, use it as a reference for both examples and then just for basically documentation to know which nodes are exceptions to the regular function of n8n nodes. So go ahead and download it in the link, and we'll see you in the next one.